friends. So in the last session we were discussed that here. So definition is also important. So you know the physical quantity like mass, weight, temperature, and density and volume. So in that I think we have stopped at particular temperature itself. So let's continue this session with this particular concept, guys. So temperature is being here one of the physical quantity of a matter, and that can expresses that here a common perception of hot and as well as that cold. Okay, so this is a particular temperature as we know that. And by the way, so we have that different scales in order to express the temperature here. They are could be like that. So one will be here degree Fahrenheit and degree Celsius and as well as that Kelvin. So among these three particular stuff here, so Kelvin is an here SI unit of temperature itself, isn't it? So we have to discuss today, that is conversion of how do we convert here degree Fahrenheit to degree Celsius. Or you know that so from Kelvin to degree Celsius. So let's do these particular conversion. So let's have a concept. Okay. So suppose conversion of so degree Fahrenheit to degree Celsius. Okay. So we have a certain formula. So degree Fahrenheit which equals to 9 by 5 of degree Celsius plus 32 guys. So this will be the formula for conversion of Fahrenheit to the here degree Celsius. Okay, and this will be the formula guys. Okay, so suppose we have that any particular value in that degree means Fahrenheit means we have to convert it into degree Celsius means, so we have to know that go through with this particular formula. Okay, so next conversion of Kelvin to degree Celsius or degree Celsius to Kelvin, whatever. Okay, conversion of Kelvin to degree Celsius or so degree Celsius to Kelvin here, degree Fahrenheit to degree Celsius or degree Celsius to Fahrenheit. Just you can know. So rearrange the term here. If you want to degree Celsius means, then the formula will be here. So 32 is degree Fahrenheit minus 32 into 5 by 9 will be there. So this would be the formula. So just make a small rearrangement here. Okay, then you are going to get a conversion of degree Celsius to Fahrenheit. Okay, so then suppose we have that here Kelvin. Suppose we have means that conversion of Kelvin to degree Celsius means degree Celsius to Kelvin means, so we have formula is so 273.15 plus degree Celsius. So this will be a very simple formula. You guys know that very well. Okay. So or degree Celsius which equals to so how to do is that so you just make a rearrangement here. Okay. Thereby we are going to get a minus 273.15. Then we are going to get here this particular step. Okay. So this is the termination we have to get here. So Kelvin to degree Celsius and degree Celsius to Kelvin. Whatever that you guys know that you have to convert, you should do this. You should use these particular formulas. Okay. So this is the thing, guys, and we have to know that here. So among those so degree Fahrenheit and degree Celsius and Kelvin. So among these three particular scales of and temperature, where we are going to get here negative values for that degree Fahrenheit and as well as a degree Celsius. But we always been getting here a positive value for that here Kelvin. So take it down. Okay. So note. Okay. So degree Fahrenheit and degree Celsius should have means that possibility is there. Negative value they can show that. Okay. So should have that negative. So degree Fahrenheit, degree Celsius should have that negative values. But whereas Kelvin always be positive. So this we have to know that. So degree Fahrenheit or degree Celsius, we know that here minus 25 degrees Celsius. Okay. So but we know minus 25 Kelvin. Okay, we cannot pronounce like that. Why? Because the thing is that degree Celsius and degree we can express that in here. So they should have that negative terms. Okay, actually, but we cannot have such kind of thing for that Kelvin. Kelvin always be an positive brackets. Okay, so this is the stuff we have to know about here. Small thing by the way. Okay, but we have to know that particular concept. Okay, so this is the thing, and we shall discuss here right now one of the most important concept, that is a scientific notation skills. So which is most and most important. So let's do that particular concept here. Okay, please stay on this one. Okay, so these are the very simple terms where we can convert here degree Fahrenheit to or degree Celsius, or from degree Celsius to degree Fahrenheit, or Kelvin to degree Celsius, or degree Celsius to Kelvin. So with the help of these particular formula, which are very simple and very easy. Okay, so let's go with that here. One of the most interesting concept, that is scientific notation. Scientific notation. See guys, so before knowing this particular definition of the scientific notation, we have to know some brief concept regarding the here scientific notation skills. Okay, so what is that scientific notation? Why do we need the scientific notation skills? The thing is that, so as we know that already, chemistry which can involve that here study of small particles like proton, neutron, and electrons, and atoms, ion, and molecules. And you can see their particular masses means will be very small, right? Masses of these particular particles like ions, ions like atoms like, and masses electrons, proton. So mass of these particular small particles is going to be very small, as we know that. But the number given in that amount of a substance is which is very large. Okay, so what I mean is that, say for example, you can consider here 1 gram of hydrogen, 1 gram of hydrogen which contain, so I must write here. Okay, so 6022 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. See, 1 gram of hydrogen which contains this much of atoms. Okay, but so masses of each hydrogen have the value which is 0.0234 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22. Okay, so this much is. See, the thing is that, yes, absolutely. See, 1 gram of hydrogen which contains this much of an atom, and masses of each and every hydrogen atom, mass of each hydrogen atom, so which weighs here this much weighs. Okay, so the thing is that if you can take here any particular constant, not only this one, if you can take here, so you know the speed of light, okay, or you can take here charge and electron, or you can take Planck's constant value. Okay, so those values can have also the similar magnitude. Okay, but the thing is that where we have to got an really confusion means, so very difficulty means that, so it's absolutely a real challenge to do that mathematical operations like addition, subtraction, and division, multiplication, such with these kind of numbers. Okay, so hence here, see, in order to solve this particular problem, where we can use that here scientific notation skills. Okay, in order to that, so do you just imagine, is it possible to multiply these kind of values, or is it possible to divide, or it is possible to operate that mathematical operations like addition, subtraction, multiplication, division, these kind of values? Never. So in order to solve it here, so we are going to be using the scientific notation skills. Okay, so then what is meant by actually scientific notation? So let's talk about that thing. So please know that this is in order to get to know the scientific notation, this is nothing but here a pre-concept, right? Okay, so we have to note this particular thing here. Okay, so where we have to failure to multiply or divide, so division, to make a division or to make a multiply, to make an addition with these numbers, so it is highly impossible, not impossible, it is somewhat difficult. Okay, so that's why we have to make it that easy, that we are going to using here scientific notation. This is the thing guys. So that's why, so let us go with that here scientific notation, what it actually, okay, so what it actually stands for. Yes, scientific notation is nothing but here exponential notation of notation of a number, exponential notation of a number where number can be represented by in this particular formulas a into b, a into 24 of 20. So this is the thing we have to know about. So scientific notation. So scientific notation is nothing but here exponential notation of a number where number can be represented by in this particular formulas. So a into 10 raised to p. So where a can be here any real number. So a can be here any real number. Okay. So and b can be here so integers. B can be here integer. So where a can be here any real number. Okay, any real number. So this is the thing we have to know always. Okay. So scientific notation that can solve in that here that so large magnitude of number means so we are not able to multiply or we are not able to divide, we are not able to addition or subtraction. That's why we are going to make a use of that here scientific notation. With the help of scientific notation, we are going to do that mathematical operation. So with that large a large magnitude of numbers. Okay, so this is the thing, right? So let us do here some important. So how do we convert that a large numbers with that scientific notation? Okay, so let's do that for you. Okay, suppose let's make an here a table. Standard, very simple concept by the way. Okay, standard decimal notation, and scientific notation. Standard decimal notation and scientific notation. So you guys really know this particular concept already, but we have to know again. We are going here. That's it. Suppose we have some values. I just go here. We have that. Okay. How do we convert this number with that scientific notation means? Okay. So I just have to get 3 into 10 raised to. Okay. So here scientific notation is nothing but here exponential notation of a number where number can be represented in this particular form. A into 10 to the power of 3 into 10 to the power of. Okay. So next, you have a huge number here. Okay. So if you are expressing in terms of scientific notation means how it would be? Okay. So 1, 2, 3, 4, 5, 6, 7. So 5.6 into 10 raised to 7. Isn't it? Okay. So next, if you can have it here, so minus 65,000. So you have this particular number. Then so minus 6.5 into, you can take any values and just have to, so whatever things comes in my mind, I just write it. Okay. So 6.5 into 10 to the power of 4. Okay. So I can write here 0.00004282. So how do you know that so express this value in the terms of scientific notation? Yes. So we just have to shift in here decimal point here. 1, 2, 3, 4, 5. So 4.281 into 10 raised to 9. Okay. So this is a very simple concept. You guys already know. I know that. Okay. So this is the thing, guys. So this is the role of that scientific notation. Okay. So please take them here. So let's go with that calculations. So which is involving here scientific notations. So if suppose you can do that here multiplication, division, or subtraction, or addition with the help of scientific notation. So how actually we are going to operate that, so values with that scientific notation space. Okay. So yes. So know that multiplication and division using scientific notation. Multiplication and division using scientific notation. Suppose I have some value. Okay. So if I do that here multiplication. So I am telling you, you guys really know these things, okay? But for formality, I am doing it, okay? So I have some value into, okay? So how do you simplify this particular term here? How do you multiply with huge numbers? Okay. So that's why we have to go with that here scientific notation. Suppose you can, convert this particular term as scientific notation is. So then we are going to take for this particular value, that is, so 5.6, 1, 2, 3, 4, 5, 6. So I am going to take it here. So 10 to the power of 6 into. So here 1, 2, 3, 4, 5, 6. 6.5 into 10 to the power of 6. Then we have to multiply these two numbers. So 5.6 into 6.5 10 to the power of 6 plus 10 to the power of 6. 6 plus 6, which is 12. Then 5.6 into 6.5 10 to the power of 12. So you can multiply these two values. So you got some values here. You just have to put here as a x. The x can be here the simplification form of these two values. You do that multiplication, you got some values here. Okay. So into 10 to the power of. So this is the kind of a method where we can solving here a huge number with the help of scientific notation. Okay. So you just know that multiplication how to done in this particular form. That's it. Okay, you can have any particular huge values means. So in terms of scientific notation, you can go through means that. So then it will be very easy to calculate. Okay, so that only I have done it. Okay, so let's take that here. Next, if you can do here division. So division with a scientific notation. Okay. So division. So suppose 0.0027 into 56,000. Okay, I don't know, simply I just wrote here number. So how do we simplify these particular values here with the help of scientific notation? So using scientific notation, we are going to that so simplify this particular value 0.0027 divided by 56,000. Okay, then what we have to actually do here first of all. So you just convert this particular term as the form of scientific notation. Then what? So what might be the value we are going to get there? So 2.7 into 10 raised to minus 3. Isn't it? So 1, 2, 3, 2.7 into 10 to the power of minus 3 divided by. So here 5.6 into 1, 2, 3, 4 10 to the power of 4 is. Okay. So 2.7 divided by 5.6. Okay. And we have a 10 to the power of minus 3. So this particular term will be the numerator what we are going to get here, 10 to the power minus 4 plus 4 to denominator 2 minus, so numerator we are shifting means, so positive charge becomes negative and negative charge becomes positive, as we know that. So if you can solve this particular term, we are going to get here some y value here. I am just writing here for imaginary value, just simplify here, you get here actual value there. Okay, then 10 to the power of minus 3 and minus 4, which is minus 7. Okay, so this is the thing. So this is the method of that solving huge number with the help of scientific notation. So as in the form of multiplication, division, addition, subtraction. Okay, let us see that here. So how do we add these numbers, subtract the numbers with the help of scientific notation? So we can go with that. Okay, so addition by the way. Addition. So let us have some numbers here. Okay, so I just have right here 2.5 into 10 to the power of 4. Okay, so plus 6.58 into 10 to the power of 3. Okay, so we have this number and we have to add up these two. We have to add up these two numbers. So then only do this. But here power is going to be different. Okay, when we have to add up the two terms and those two particular terms as in the form of scientific notation, then their power must be same. Okay, their power must be same while doing addition as well as that subtraction. So I just have to write this term as it is 2.5 into 10 to the power of 4. Okay, so and just have to make a rearrangement with this particular number. So 6.58 means I just have to shift one decimal point towards left side, thereby 0.658 into 10 to the power of 4. Okay, the power becomes here same. Then you just have to take a common term here over 2.5 plus 0.658 into 10 raised to 4. So you just add this number, you got some value that is. So I just have to write here like that. So into 10 to the power of 4 into 10 to the power of 6. Okay, so this is the thing we have to know about here. So with the help of scientific notation, how do we get into the here addition as well as that, so subtraction, these mathematical operations. Okay, so let's go with that here, division. Sorry, subtraction. So we have number. Okay, so 5.8 into 10 to the power of minus 3 minus, so 7.58 into 10 to the power of minus 4. Okay, we have here. So in order to simplify these two particular term means, so there must be the power has to be same. So that's why I am going to rearrange this number. I don't know, simply I have write the number what, so this comes in my mind. Okay, so 5.8 and these are a big thing minus 3, and so I have to make an rearrangement and I have to shift the decimal point. So let's go over 0.5758 into 10 to the power of minus 3. Okay, one we have to shift in that number means that it becomes here 10 to the power of minus 3 guys. So why? Because you are dividing here by 10. Okay, thereby you are going to get here 0.758. Okay, so then 5.8 minus 0.758, so into 10 raised to minus 3. So you got there over some values which is b into 10 to the power of minus 3. So it has some values guys. So okay, you just simplify these numbers. Okay, then you got that actual number. Okay, so this will be the kind of a method guys. So we have to solve with that any particular values. So either it may be an addition or multiplication or division or subtraction with the help of scientific notations means. So we have to carry these things. Okay, so very simple concept and you guys are very well known about these things. But for a formality purpose, we have done here. Okay. Okay, guys, let's take down. Let's go with that here. Another most important concept that is precision and as well as that accuracy, which are most important. Okay, so let's take up this concept. That's right. precision and accuracy. Precision as well as the accuracy. See what is mean the precision and what is mean by accuracy here. So most important thing is so precision and accuracy. So how do we know that we can differentiate between that? So precision and as well as the accuracy. Okay. So let us consider. So we are in a lab. Okay. So if one student is doing titration. Okay. So I am just that conveying you guys that is so how do you know that so find out that values which are precise value and which are accurate value. Okay, so this is the thing I want to express in you guys. Okay, so the thing is that precision and accuracy. Okay, so how do we differentiate the term in between some values? Okay, so the thing is that if a student is doing here a titration means, so he is titrating 10 ml of a base solution with here acid. Okay, so or an acidic solution with here base. Okay, so he is doing titration here. Okay, and that actually the true value is going to be here. Suppose let us consider the true value is going to be 10.5 ml. Ultimately, we are going to be get here endpoint as in here at 10.5 ml. But a student is doing an the titration. Okay, with the help of that titrating 10 ml of so a basic solution with an here acid means that he is going to get here titrate value as in here 11 ml. He is going to get here titrate value that is 11 ml. Our actual true value is to be here 10.5 ml. But he is getting there over 11 ml in the first trial, and in the second trial he might have get there over. Let us simply assume that 10.9 ml, and in third trial you would get here 11.1 ml. Okay, you just consider here these three particular so values. Okay, where the student got in the titration. Okay, but our actual agenda is that here the true value is to be here 10.5 ml. Our target is to be here this value. But unfortunately, the student, if you are getting there over so 11 ml, 10.9 ml, and 11.1 ml. Okay, so these three values are close to one another. Okay, so close to one another, but these three values are not close to this particular value. Okay, so 10.5 ml that is actually true value. Our main target is to be here 10.5 ml. But unfortunately, the student he got there over so 11 ml, 10.9 ml, 11.1 ml, and these three values are very close to one another, but which is not close to the here a true value. Okay, that's why these three particular values are considered as a here precise values. Precise value. It is not an accurate value. Okay, so you just that I hope you guys are understanding this particular thing here. So 10.5 ml that is our true values. So it could be our true value. Our main target is to that here we have to get this value particularly. Okay, but he's that got there over 11 ml, 10.9 ml, 11.1 ml. These three values are close to one another, but these values are not close to the true value. Okay, so he made a measurement. Okay, but this first trial he got 11 ml, second trial he got 10.9 ml, in third trial he would get here 11.1 ml. So these three values are, you can take any single value, they are not close to this value, but you can take any single value, they are very close to one another. Okay, so hence these kind of a value we can call it as a here precise value. Precise value. Hence that here. So if we are considering here, next suppose let me go with that here. So another accuracy. Then you guys come to know it. So accuracy is nothing but here. Another student is also doing titration. The same thing. He follow the same thing there over. He is also titrating with an 10 ml of a basic solution with an acid, and he might have been get there over a titrate value as an there over. Titrate value has been he is getting 10.4 and 10.5 and as well as the 10.6. Okay, so these value you can consider means, so these value behaves as both precise and as well as the accuracy. So these value behaves as under both precise and accuracy. Okay, why it is precise? Because these values are close to one another. Why it is accuracy means, so you can take any single value here, this single value which is close to the true value. Okay, that's why these particular values are here gives as both precision as well as the accuracy way. So you made many measurements, so in that measurements the value what you are going to get, that value should be closer to the here true value, then only it would be that called to as a here accuracy. And you have done there, or you have made many measurements, so in this measurement you got some few values, and those values are not actually close to the here true value, but they are close to with one another itself. Okay, hence those values can consider as a here so precise values. Okay, so this is the contrast we have to know about in between, so precise value and as well as the accuracy. Okay, so this is the thing, right? So let me know that let us go into a particular definition. I hope you guys understanding here. So precise and as well as the accuracy. Okay, so let's go with that. Okay, so yes, so let us